Alright, so this is for your fifth homework problem, and we're looking at function notation. So let's say I have the function y equals 3x squared plus 4. Say that. Y equals 3x squared plus 4. So a couple of different things that function notation is good for. Let's say I had a list of functions here. Y equals 3x plus 4, y equals 7 square root of x, y equals x minus 5. And I tell you, plug in x for y. Do you know what equation I'm talking about? Yeah. So let's say I have this list of 3 functions right here. If I tell you to plug in 7 for x, you're right. So this gets crazy. You're gonna think I am dealing with some crazy system, or I gotta plug in 7 for every single value. So having them all equal to y, there's really no clarity when I tell you to plug in a value. So function notation, what it does, it gives me a way, an outlet to actually name all of my functions. So if I tell you to plug in a value, you'll know exactly what function I'm talking about. So let's rewrite these 3 equations using function notation. So function notation is going to consist of another letter. So usually it's going to be F, G, or H, but it could be any letter. I could have A, S, Q, R, V, it doesn't matter. I'm using this letter to name my function, but I'm going to go with the standard F. So the first letter, this is the name of my function. So I'm calling this first function f. And the thing that I plug into this function is x. Right? So this is f of x equals 3x squared plus 4. So the way we say this is f of x, where f is the name of my function. F is the name of my function. Alright, so let's do the same thing for the second function. Now I named the first one F, so I don't want to name the second one F. Give me another letter. Alright, G. So the second function will be G of X, right? I'm plugging in X, so my variables need to match up, and I'm going to name it G. So now when I want to talk about G, I can call it G, and you're going to know what function I'm talking about. And then this last one, I don't want to use F, I don't want to use G. Let's use a different letter. Y'all don't want to be original, but alright, we'll use H. So H of X is the square root of X plus 3 minus 2. Alright, so now they all have names. So if I want you to plug a value into a specific function, I can call it by name and tell you what function I actually want you to use. Right? So there's one perk of using function notation. The second perk is if I'm actually asking you to evaluate these functions at a certain value of x. Before we named them, if I wanted you to figure out what y was equal to on this first function when x was negative 2, I would have to tell you either determine the y value when x is negative 2 or plug in x equals negative 2 or something like that, right? I'd have to use words. And in math, I would rather not use words. We're fancy, and I want to use symbols and things like that. So what function notation does is it allows me to show that I'm going to evaluate the function in a certain place without actually having to write it all out. Remember that the value that's inside the parentheses, this is what goes inside my actual function, right? I have x here, x is what's inside my function. I have x here, x is what's inside my function, and I have x here, x is what's inside my function. So if I ask you to do this, what function am I talking about? H, function H, right? So this last function right here. And what am I asking you to do to it? To plug in 6 for the x, right? I replaced x with 6, and that's exactly what I'm asking you to do. Replacing the value means I want to evaluate h when x is equal to 6. So seeing that notation just simply means I'm going to replace the x value with 6. So this gives me the square root of now 6 plus 3 minus 2, which gives me the square root of 9 minus 2. Square root of 9 is 3 minus 2. So h of 6 is 1. That's what function notation is used for. Okay. 1, to be able to name my function, and 2, to allow me to evaluate my functions. Okay? Questions on function notation?